Today, we are going to solve a problem on isometric view. The question is, figure shows front view and top view of an object. Draw isometric view. So, the reference line is XY line, which is of blue color, above which there is a front view, and below the reference line there is a top view, according to the first angle projection method. So here, first we have to find out the maximum dimensions of these two views, and we have to form a cuboid of maximum dimensions length. Okay. So here, if we observe the front view, so from O is nothing but a origin. The whole diagram means front view is towards the right hand side, which is having 30 to 30 plus 60 millimeter length. So total it is 90 millimeter length. So 90 is the maximum dimension in front view. So here in isometric view, we have to draw the isometric axis. Let's say this is the isometric x-axis. This is y and this one is z, which are having the 30-degree inclinations to the reference line. So first we will draw one reference line, mark a point O origin, and we will draw two lines having the 30-degree inclination to the reference line. And as my front view is towards the right hand side, means on a right surface. So my dimensions on the right surface are 90. So here from O, I will draw a line of 90 millimeter length. Same way in front view, what is observed? The height of the object is observed. So it is 60 millimeter. So from O, straight vertical, I will draw one line having dimensions of 60 millimeter. Okay. And the left hand side length. So that's observed in top view. It is 15 plus 15 plus 15. It is 45. So on the left hand side, from O, I will draw a line of 45 millimeter length. So now we have to complete this cuboid. Okay, let's say from I will copy this line, same line I will draw. It is of 90 millimeter length, and here same line 45 millimeter length. Then this same line of 60 millimeter length. 60 millimeter length. Okay. Then this is of 90 millimeter length. And again, the same line of 45 millimeter length. To understand, I will give you the dimensions. This is a line. So this length is of how much? 90 millimeter. This height is of 60 millimeter length. And width or left surface maximum dimensions are 45 millimeter in length. Okay. Once we have done this, so the whole object will be within this box only. not a single line will go outside this box. Okay. So this box may be or may not be part of our diagram. So next, it will be better if you observe the front view and top view and try to match each and every projection coming from front view with the top view or in both the views. So here, if we drop a projection from this line, so it matches with the projection in a top view. Same way here, if you draw a line, so we will try to match the projections in front view as well as in top view. So the projection coming from this outline matches with this in a top view, first and second line. Then projection coming from a front view from this dotted line matches with this slot. Why I'm saying a slot? Because here this line is not connected. So there is a slot in a top view, let's say rectangular or U cut shape. Okay. Same way here projections coming from ends of this circle are matching with this two dotted lines in top view. So what this suggests, if we try to analyze this whole object, then there is a circular hole in a front view and this is throughout. So that's why it is not visible in a top view and we are having these dotted lines throughout in top view of 45 millimeter line. Same way here, there is a slot in top view and this dotted line suggests that it's not visible in a front view. Okay, so that we have to draw it on the top view or top surface from a top surface. Here, this is an inclined line. It is starting from this location and ending at this location. This is the inclined surface. But if you try to find out the projections of this line in the top view or match with this, then we are having only two lines. This is one and this one is second, which is starting to end of this inclined lines projections. So means this is a totally inclined surface as well as these two lines are also on inclined surface. So that is a inclined rectangular slot you can say. Okay. So by having this observation, we can actually start to draw the object. So first, let's say we will draw this baselines, okay, from O, which is having the 90 millimeter line. Let's say from here, we will draw a line having the 90 millimeter length. This is 90. Okay. And this height is of how much? 60 millimeter. This height is of 60 millimeter. So we will draw a line having the 60 millimeter line. So here at the top of this 60, so there is a line of 30 millimeter to the left direction or left side. So from this top end, you have to draw a line having the 30 millimeter length. So here on this 30 millimeter, you have one and two lines. So same way from this, you have to draw a line of 30 millimeter length. Okay. And this line is of 45 millimeter length. So just join this 45 millimeter length at the top. Okay. So from this 30 millimeter length, this inclined surface starts and where it ends at 30 millimeter height from base. So where is base? So this is the base. So from base, the height is 30 millimeter. Yes, same way. From this, the height is 30 millimeter. Okay. Same way, here there are two lines of having how much dimension? 15 and 15. So here you can draw 15 plus from this side 15. Okay. And your inclined surface end starts from this and end at this location. Correct? Okay. So now here the horizontal dimension that has given, it is of 60. For what? For this rectangular slot, or you can say from a O, it is 30 millimeter. So from O, I will take a 30 millimeter length and will draw a projection upwards till it intersects this inclined surface. Okay. Why? To find out where this rectangular slot ends. So same way, now we have got the location. So this is 30 millimeter length. Okay, this is 30 millimeter length, and from its straight vertical projection on the inclined surface. So from here, straight vertical projection on the inclined surface. So wherever it will intersect, we will got the location of this or end of this slot. Okay. So here we will draw, let's say, a line having 45 millimeter length, a reference line. Okay. So now to complete this rectangular slot, here we have to take how much dimension? No, not the dimension. We have to just draw the parallel lines to this inclined surface. So once we have drawn the parallel line to this inclined surface from these 2 points, now we can complete this slot. Now, just from this, we have to draw a line having the 30 millimeter length. Same way from this point, 30 millimeter length. And this is 15 plus this is 15. Okay. So as well as here from this point, we have to draw a line in this direction, parallel to this direction, or this, let's say, OY isometric axis. So till it intersects the object. So here it intersects the object. It shows the continuation of the slot from the starting to the end. So now we have to draw the circle where its center lies 30 millimeter from the right hand side to the left of an object. Let's say from this right end, its center lies on a 30 millimeter length. And here we have not given directly the distance of this center point from the base line, okay, or the base. So if it is not given, we have to assume that the center lies at 30 millimeter length. So here the center line is at the 30 millimeter length from the baseline. Okay, and 30 millimeter towards left from the right end. Okay, so we'll try to find out the center point. Okay, so we'll draw constructions lines, let's say, from here, straight vertical, how much? 30 millimeter length. And then, so we have got the center point of this circle. So, but here, as it's a circle, it's not a circle, isometric circle. So it will not at all looks like an circle, it will looks like an ellipse. So there is a method to draw the isometric circle, and that method is called as the four center method to draw the isometric circle. So here we have to inscribe this circle in a rectangle, or let's say the square, and we have to draw that square, means it will looks like a rhombus here on a right surface. Why on the right surface? Because this circle is in front view and my whole diagram is towards the right hand side of this O. So it is on the right surface. Okay. So here, if we inscribe this circle in a square or a rectangle, let's say, so maximum dimensions will be equal to the diameter. So its diameter is 30. So we have to draw a rhombus of 30 by 30 millimeter dimensions on a right surface. So how to draw it? Let's say so this. So how to draw this rhombus of 30 by 30 dimensions on the right surface. So take this distance equal to 15 millimeter, and to the left and to the right, draw a distance equal to 50 millimeter. So it will be 30 millimeter in total. So we have to draw this 30 millimeter length. Then straight vertical below 30 millimeter, in this direction 30 millimeter, and in this direction 30 millimeter. Okay. So now this is the rhombus, okay, that we have drawn. So according to the four center method to draw the isometric view, the construction says we have to draw this is a rhombus of 30 by 30 millimeter dimensions. And according to the four center method, you have to connect the bigger diagonal of this rhombus. So this is the smaller one, and this one is a bigger one. And from its any opposite corner. So from either this corner or this corner of a rhombus, you have to connect this corner with the opposite side's midpoint. So here is a midpoint. Same way, opposite side's midpoint. And here, this corner itself will be the first center. Why this method is called as a four center method? Because we have to draw the four arcs from the four centers. So here we have got the first center, and radius is these two lines. These two lines are having the same length. Okay, same length. This is a V. Okay. So what we will do, we will put one end of your compass here and we'll take this as radius and we'll complete this arc. So this is the arc. Start from here, center here. Same way, this opposite corner will be the center for the another arc and radius will be same. Okay. So the same, we have to connect this corner of a rhombus with its opposite side's midpoint. So let's say from this to here is a midpoint. So from this corner, so this is the opposite side and this is the midpoint. And now we have done the construction and we have got the four centers. Where we have got the four centers. So this is our first center, this one is second, this one is third, and this one is fourth. Okay, so we have to draw the four arcs from these four centers. So what is the radius then to draw the larger arcs, two larger arcs and two smaller arcs? Okay, so two bigger arcs, two smaller arcs. So this length of the V itself is a radius. Okay, so you have to draw an arc considering this as a center and this whole length of a V as an radius. Okay, same way, this V is having the same length or same radius and center will be here and we have to draw an arc, bigger arc. Now here, from these two remaining centers, we have to draw the smaller arcs. So this will be center and this V as a radius. So these two lines are having the same length. This is the first arc. This is second smaller arc. Now we have successfully drawn the isometric circle, and our isometric object or view is ready. After drawing this, just to complete the isometric object. So here, from here, we have to draw a straight vertical line till it intersects the object. What it will suggest? It will suggest there is a slot from this point and it is up to the base. So that's why we have to draw a line from this corner till it intersects the object. Okay. And now we have successfully completed the isometric view. So hope you have understood very well how to draw an isometric view or object from given views. Thank you.